For the first video of the year, we really kind of hit on a lot of random stuff here, but it's just meant to be a review, so let's just hop into it. First of all, let's graph the numbers and write an inequality to relate them. What does that mean to graph the numbers? Well, that just means to put them on a number line. And before we can do that, it's a good idea just to get a decimal representation for each of the numbers. Now you can grab your calculator, just divide 5 divided by 4, and we get 1.25. And when it comes to the square root of 3, that's 1.732. Now that we have that, it's a lot easier to graph the numbers. So we just need a number line. And I see that both my numbers are between 1 and 2, so maybe we will label our number line as 0, 1, 2, and then just put dots where we need to. Well, 1 1/4 is about here, and 1.7 is a little bit closer to 2, so it's over here. Now we should also label those numbers right next to it. This one being 5/4 and the other one being square root of 3. There, we've got the first half done, graphing the numbers. The other half is to write an inequality to relate these two numbers. So what we want is 5/4 is related to square root of 3 somehow. Well, one's bigger than the other. And we know, we can see, just because the square root of 3 is more to the right, that the square root of 3 is bigger, so we grab our inequality, which means that the square root of 3 is bigger. So 5/4 is going to be less than square root of 3. Some properties for addition and multiplication. These words, I'll use them throughout the class, and we do need, they are helpful in simplifying expressions or solving equations, things like that. First of all, the commutative property. For addition and multiplication, what commutative means is like commuting the work, going back and forth. The commutative property tells us that order doesn't matter. So if we have A plus B, we can add them in the opposite order, and we'll still get the same answer. 5 plus 7 is the same as 7 plus 5. And multiplication works the same way, that we can multiply in either way, and we'll get the same answer. The associative property says that if we have a few things that we need to add or multiply together, order doesn't matter there either. So if we want to add together A plus B plus C, I can add the first two things together first and then add C to it. Or I can add B and C together first and add it back into A. Same thing for multiplying. I mean, if we're going to multiply three things together, A times B times C, we're going to get A times B times C. And it doesn't matter if we multiply those first two things first or the last two things first. So far, all properties have been the same for addition and multiplication, but identity is where they start to change. And the identity is keeping things the same. For addition, if I want to add something to a number and keep it the same, what would I have to add? Well, it's obviously going to be 0. For multiplication, though, it's not the same. If I want to multiply by something to keep it the same, we're going to have to multiply by 1. And inverses are going to be those things that we combine that will give us the identity. So for an inverse, I'm going to take a number and I'm going to add something to it to end up with our identity, 0. And in order for addition, what I would have to add is the opposite of A. For multiplication, if I want to multiply by something and end up with the identity with 1, I have to multiply by the reciprocal. And then the distributive property is another one that we should feel pretty comfortable about, that if I'm going to have multiplication and addition, oops, that's supposed to be a C, we distribute the A to both of them, so we would multiply A times B and add it to the product of A times C. Now, initially, all these properties are just kind of confusing. A lot of letters just plop down on a paper in front of you. But this is really the framework that allows us to internalize how numbers work well together. And we feel comfortable with them. When you think about any of these individual properties, you should feel comfortable about the associative property, and say that we have 3 plus 9 plus 7. We could go through and add them all up in the order that they are, but I could also rearrange them and combine these two together first, because I see that 7 plus 3 is 10. And so when I add 10 to 9, I get 19. And it allows us to do that arithmetic in our head quickly. The other important thing about these properties is that they only work for addition and multiplication. Lots of times we want to extend these properties to all sorts of operations, all sorts of numbers, and that doesn't work. All right. If we, for subtraction, say if we subtract in different orders, say that we have 3 minus 5, that's not going to be the same as 5 minus 3. Right? It gives us a similar number, but they're going to be opposites of each other. And same thing with multiplication. Just because it works for multiplication doesn't mean it's going to work for addition or division. We have to be careful of all that. Some unit analysis stuff. Let's just answer these questions. A couple of simpler ones. You work for 4 hours at 36, and you get $36 for that. What's your earning rate? Well, when we think about earning rate, we're thinking about how much do we make in dollars per hour. And so you think about the units and then attach numbers to them. Since we want to find out our dollars per hour, we're going to put the dollars on top, $36, and divide by the number of hours, 4 hours. And do the math on the number part. If we take 36 divided by 4, we get 9. So that means our earning rate is going to be $9 per hour. You travel 2.5 hours at 50 miles an hour. How far did you go? Something that we should feel very comfortable with is the distance formula. Distance equals rate times time formula. And we can just plug things in. If I want to find out how far we went, that's our distance. The rate is the thing that has per in it, miles per hour. And the time is 2.5 hours. So we have it all set up, and we just have to multiply it out, and we get 125. But the thing is, we should be looking at units. So I'm going to back it up a little bit here. And let's take a closer look at our units. When we look at the rates, that's 50 miles per hour. And the time is 2.5 hours. As a fraction, that's just over 1. And the thing that we know about multiplying fractions is that if we have a factor in the numerator that's the same as a factor in the denominator, they cancel. So those hours, since we got an hour on the top and an hour on the bottom, they cancel with each other. And then we multiply out, and we'll get that same 125. But what's our units? The only one that's left, miles. Lastly, this is a very common problem. It comes up in a lot of different forms, asked in a lot of different ways, but it's a unit conversion problem. If you're driving 45 miles per hour, what's your speed in feet per second? So what we want to do is take that 45 miles per hour, miles per 1 hour, and change it from miles per hour into feet per second. That's why we call it unit conversion. We're converting the units from one form into another. We see that we have two parts, the miles and the hours. And I'm going to just take one of those and change it into what it needs to be. So first of all, let's take the miles and change it into feet. And the thing about that is I know that 1 mile is equal to 5,280 feet. It's a Googleable fact. We can look it up and find that out easily. So what I'm going to do is I'm going to multiply by a fraction. And this fraction that I'm going to make, I'm going to put 5,280 feet on top and 1 mile on the bottom. In essence, because these two quantities are the same, those two distances are the same, we just see that they're the same right here, they're equal. I have the same thing on top that I have on bottom. So they cancel each other out, and we're multiplying by 1. And that means that we're not going to change this quantity at all. The number might look different, but by changing the number and the unit, it really does keep things the same. The other thing about it is that I've used this fraction with the feet on top and the miles on the bottom. I could have done it the other way around, with the miles on top and the feet are on the bottom, and it'd still be multiplying by 1. But I want the miles on the bottom because of what we just did in the last problem. I'll have that factor that's the same. Miles on the top, miles on the bottom. They cancel each other and just leave us with feet. The next thing that I want to deal with is going to be the seconds. And what I know about 1 hour is 1 hour is 60 minutes. And not 60, but 1 minute is 60 seconds. And we can use these two to create those fractions again. And so let's just change hours into minutes. I'm going to do that by, I have an hours on the bottom, so I'm going to put hours on top. 1 hour on top is the same as 60 minutes. And what that'll do is it'll cancel the hour with the hour, and now we're left with minutes. We don't want feet over minutes, we want feet over seconds, which is why I'm going to need a second fraction here, that 1 minute is 60 seconds. Then our minutes are going to cancel, and we'll be left with just seconds. Feet per second when we look at just the units. Now, the last thing we just let our calculator do to help simplify everything for us. We've got it all laid out, and we can just go through, multiply the entire top together. When we do that, 45 times 5,280 feet, that's going to be 237,600 feet. When we do the same thing in the denominator, 1 times 60 times 60, we'll get 3,600, and the only units that are left there are seconds. One last thing arithmetic-wise to do is just to simplify this part. Take the 237,600 divided by 3,600, and what we're left with is 66. Don't have to worry about the units. They're sitting right at the end here, and our answer is going to be 66 feet per second.